there. Welcome back to Stay Sharp in Digital Engineering. So glad you're here today with us. It means a lot that you participate. We know that you have a lot of things you can listen to, and we definitely appreciate you listening in to our episodes. And today's episode, I think you're going to really like. It's a little bit of a different one. So Jonathan and Scott and I sat down with Mike Finocchiaro again. But what was interesting about this one was Mike recently looked at more than 300 startups across the digital engineering space to characterize where innovation will be coming from. And that will certainly disrupt the marketplace that we know today. Because we know there's some really interesting technologies coming out. So from global hotspots to new tech startup categories that he's defined, he takes a look at where agility, AI, and investment is driving the future of digital engineering. So without further ado, let's jump in. All right, everybody, welcome to Stay Sharp, the podcast about all things digital, from products and engineering to manufacturing, service, and more. I'm one of your hosts, Julianne Grant, and I am joined by my co-host today, Jonathan Scott.
Hey, everybody.
Hey, Jonathan. And
I love it, Fino. You're like pointing this way, and I'm like, wait, hold on. Wait, it's Brady Bunch style.
It's like Brady Bunch.
That's right.
Oh, no, that was the podcast last week with 9. We had 12
of us. That's how I felt. Yeah, on that podcast. Exactly.
I interrupted. I'm starting early. Sorry, guys.
That's okay. It's all good. So today we have brought back a special guest with us to talk about a recent study he conducted about startups. So many of you may know Michael Finocchiaro. Welcome, Mike.
Hello.
Hey, so glad to have you back here. Mike did some research recently where he analyzed 300 startups across the PLM, CAD, simulation, MES, and industrial AI space. And he identified some interesting trends that we thought would be worth sharing here. So for some of you who don't know Mike Fino, he's considered one of the bigger PLM influencers. You'll see him a lot on his channel on LinkedIn. We encourage you to check that out. And we've had him on
Julianne was on one of my podcasts too.
Thank you, Mike. Yes, I was. I was on that last week, and that was a lot of fun. He brings together many experts in his content, so please make sure you tune into that. And so we also had him on the podcast here about a month or two ago where he helped us stack up how AI was coming into the different PLM software across the big vendors. So if you missed that episode...
And you can catch that one on the Future of Engineering Conference from Cinera. That was this week.
Okay, good. Very good.
Shameless plug.
Shameless plug. And it's all good because Mike does put out some great content. All right.
And if you don't know where to catch him, you're not watching.
Well, this is true. That is true. You're definitely not on LinkedIn then. So just a little bit about Mike, in case you don't know his background. He is a Franco-American living in France, a technology evangelist, and a consultant with over 30 years of experience in PLM, digital twin, and engineering software infrastructure. He's held many senior roles at HP, IBM, PTC, Dassault, and now advises customers, vendors, startups, VC, and PEs on digital transformation. So great on AI, great on competitive strategy, often talks with across all the vendors in this space. So knows a whole lot about PLM, MES, and what's happening in product or digital engineering, basically. So he's also the creator of Demystifying PLM and Recognized Voice on PLM, CAD, Digital Thread, and Agentic AI. Forgot that. All right.
That's right. Don't forget that one.
All right, Mike. We're not. Let's go. All right.
So, I'll jump in.
Yeah.
My question is, tell us about the research, Mike. What was the premise behind it? What were the demographics of the startups you interviewed? I mean, I know we know a little bit from Julianne's introduction about the kinds of things, but give us a little more background on what you were looking at.
Well, actually, I had a couple, I've been independent for a couple of years, and I'd had a couple of contracts with startups, who you are actually partnered already with, such as Propel. I'll be interviewing Ross actually early next month. I have Ross on for an hour. And I've also worked with Duro and a few others, and Shaper 3D. And I realized, earlier this year, after the energy of ACE and talking to some people there, I was like, there's a lot of energy in this startup market. I think that it's under researched, maybe underestimated even, because there are even unicorns there. There's a PhysicsX and Rescale that are both over $1 billion. Top is about $500 million. And I found it. So I started, I just did my own research, and it wasn't like not to take a vaccine. It's like real research, actually figuring things out, factual things. And the factual thing was that I found 50 or 70 companies on my own. Then my now friend, Blake Corder, gave me access to his database that he had done that you guys might have seen last year. I combined those and there was some overlap. I ended up with about 180. And since then, I found another 120. So, every time I look, I find another 2 or 3. I created a database, which I've got about all 300 plus. And that's with 40 or 50 different pieces of metadata, strengths, weaknesses, investment, last investment round, customers, tags, industries, all that stuff. But also I did 7 quantitative metrics. So market opportunity, technical differentiators, funding efficiency, team and execution, industry impact, growth metrics, and competitive moat. So that I could kind of rate them against each other. So I started doing these top 10 lists. And it's pretty striking. There's just so much variety. I ended up splitting them, trying to come up with some catchy LinkedIn names. You know how this game works. So I called the CAD vendors, I called them Design Intelligence. And so I've got 60 some odd in there, I think 64 now. So I mentioned Intop, but there's also Shaper 3D that I mentioned. There's Gravity Sketch, Neural Concept. A lot of really, really bleeding edge, exciting companies creating new forms of modeling that never existed before. There's also
that's the part that, let me just stop on that one. That's the part that I think is interesting is you said design intelligence and you mentioned, you got to have something creative for LinkedIn. But by the same token, you don't want to call it CAD, right? No. Because it's much broader than that. And that's kind of the point about some of this innovation, right?
Well, it is computer-aided design if we go back to the original meaning of those 3 letters. But it goes beyond that because, I've also written a lot about the history of CAD. The CAD started as something just doing Booleans on solids. It evolved into those faces of a solid are actually a mathematical equation of a surface. So we had NURBS and we started with B-splines and then we went to NURBS. Or Bezier curves and then NURBS, sorry. But what's interesting
it's okay.
is that
we won't hold you accountable for the history. It's okay.
We started with Romulus was the first kernel, and then there was ASUS, and then ASUS, some of those guys went off and created what became Parasolid and shape data, right? And so up to now, at one point, basically everybody was either ASUS or Parasolid, with DS doing their CGM and PTC doing Granite. And we were sort of in that mode of you're either do direct modeling or parametric, and you've got one of those 4 kernels, or Autodesk and HP had spin-offs of ASUS. Well, what we're seeing now in the last 5-6 years is, Intop is 2015, so let's call it 10 years.
10 years, yeah.
New modeling kernels such as implicit modeling, which is the Intop one, Gravity Sketch, which is more neural nerves, like actually using VR and AR to do modeling, Neural Concept, which merges physics and CAD into the same thing, so they can do mix aerodynamic information with the CAD and for designing. I think they've designed a boat that's going 80 knots with no motor, just a sail 80 knots. Wow. Incredible stuff, just like bleeding edge, awesome stuff. And so, I think the category, that's why I call it design intelligence, because you add AI to some of these things, you come up with new mathematical concepts that we couldn't do before, and you end up with that. Yesterday, I interviewed Leo AI, which is another really exciting startup in that area. Maor and his other partner, who I can't remember his name off the top of my head, but I talked to Maor yesterday. He actually built a large mechanical model because he said, I don't think engineers care about what people say on Reddit, which is where the elements are trained. He said, I think people care about is mechanical engineering. So he trained his whole model on engineering texts, on hundreds of thousands of hours of drawings and the way people actually work.
It'd be fascinating to know where he got that data set, because that's the big issue at AI, right? Is where do you get the data? That's an interesting data set right there. Yeah.
And so I think that just gets to why I called it design intelligence, because it's more about how do we, there's transformations that are happening in that area, which are pretty exciting.
Keep going with the categories though, Fino, because I think that was really interesting, kind of the buckets you've got people in.
The next one I called extreme analysis, because we used to call it CAE, but it's much bigger than that now. Of course, you still have meshing, but you actually have meshless FEM now. There's techniques of doing meshing without doing FEM without actually meshing. The pioneer in that is Intact Solutions of Vadim Shapiro, and there's several startups like Cognitive Design that are using his technique in order to do their models, which is kind of cool. But you've also got electromagnetic stuff. You have frequency analysis. Things that were really reserved to some small office with two guys with a PhD are now being democratized in a way because they're just pieces of software now.
Well, and it makes sense too, what you were saying about what's fueling some of this is AI is letting us see things and understand things that we didn't see before. And so then you get that little nugget of something that somebody says, I know how to apply that. And then they're off and running.
Exactly. And what's really cool, I interviewed also a Finnish startup called Quantient, who's already using quantum computers to solve things like the Navier-Stokes equation in CFD, which is just mind-blowing. And they say they're waiting for the next quantum leap, play on words, but the next leap towards triple-digit qubit machines, because we're only on like 80 to 100. So if we get to over 1,000, they're thinking they could solve an entire plane in one shot with, n variables all at the same time, because that's how this stuff works. It's just crazy.
Wow.
And that's not the only one. I found another quantum startup called BQP, who's based in India and the States, and they're applying quantum on classical computers and quantum computers when they have access to them. But there's just so many applications to this. And
so what's that bucket? The quantum bucket? Do you have a name for that one?
That's part of the extreme analysis, because it is an extreme form analysis. I only had two, so I couldn't do a category of just two. I
didn't know if you had like a crazy compute bucket or something.
Yeah, I called it extreme analysis because it was all on that. The next one I called it adaptive manufacturing. So that's like additive manufacturing and subtractive manufacturing, and maybe both, because you might print too much and then you got to remove it after that. There's a lot of vendors doing NC machining on the cloud, like Cloud NC is a good example, Limitless CNC, quite a few there. And then all these additive manufacturing companies like Up to Parts, Spare Parts 3D, and guys like that. The next category, I called it cognitive thread. So that's PLM, but also MBSE.
Okay. That's interesting you put those together.
Model-based intelligence. Materials intelligence. Well, I was thinking like these are things that are still on before the manufacturing on how we develop products, but they cover multiple areas. They have a little design, a little simulation, a little bit of preparing the M-bomb, but they're not just one of those areas, right? Whereas we put model-based system engineering, there's only a handful of them, but they don't just cover design, right? MBSE by definition is the whole caboodle, right?
Right. And I think I saw one of those that you were covering, and it was fascinating to me, right? Getting AI into MBSE seems like a logical connection for me. There's so many rules to, when we think about design, like Leo AI and that language of mechanical, electrical, each domain's kind of got its own thing. But systems engineering, that's widely applicable. So if AI can start to follow those patterns, boy, that could be really interesting.
It could be a game changer indeed, which is sort of one of the theses I found that where at least Eris and Dassault are going is that when you're doing AI, it's not just one agent. You're having literally possibly hundreds of agents, each of them very specialized in one thing. So I think as we go forward, we're going to see these architectures that become far more heterogeneous with these agents that are really good at filleting, and another one that's really good at chamfers, and another one knows all these materials and their impact on temperature and speed and velocity and all this kind of stuff in terms of, say, high-speed 5-axis machining or something.
So I want to come back to your buckets for a minute. Did we get through kind of the majority of them?
Okay, so after cognitive thread, I have factory futures. That's MES IoT. So guys like First Resonance, which I think you guys know.
That's interesting. But you made that a different bucket. You made that a different bucket from adaptive manufacturing. What was kind of the difference there?
Well, adaptive manufacturing is really the tool making the machine. MES and IoT are the entire factory, right? You're looking at
the process, the larger process. Okay.
And you're looking at, it's more of a time series problem than physics of the material meeting another material problem. That's sort of why.
Just want to make sure I was tracking kind of how you differentiated. That makes sense.
And then beyond that, I had, then it gets a little fuzzy, but I had, there's BIM. I found
yeah.
44 vendors just doing BIM, all kinds of awesome, like green, just basically buildings that are sustainable, or, how do you go from a point cloud to a 3D model of a building, all that kind of stuff. I found like 44 people doing just BIM stuff. And then I had a smaller category, which was education. I found 15 or 20 for universities, from K-12 to university of education, how to raise the next generation of engineers. And then
A worthwhile endeavor.
I found there's also augmented operations. So there's a fine line between MES IoT, where you're executing on the machine floor to create something, to the maintenance of those machines inside the factory. I decided to separate them because one was far more operations and maintenance thing than I just want to I want to optimize my OEE. Right, that's two different things. So that's basically.
I got you. I mean, it's like you differentiate. You got product and factory. You got product, process, factory, and operations of the factory. So those are the kind of your buckets there. I got you.
And then I'm tempted to keep going like into supply chain, but 300 is a lot, and it keeps.
It is a lot.
I'm just like.
Okay, so I want to ask, what out of all that, right? So you got the buckets. You've compiled a lot of this, and you've been doing deep research on these. So what did you find? If you took us through a couple of things that you're like, all right, this was interesting, what did you see?
Well, first of all, it's not all that innovation is not happening strictly in the United States. Yes, a majority of it is the United States, and naturally, a lot of that is in the Bay Area, because that's where all the VCs are, A16Z and all those guys. However, Boston is also huge. Absolutely huge, because of MIT and because of the history of the 128 Tech Corridor. New York,
they've got a lot of history. It's kind of a fertile ground for a lot of that. Yeah,
it certainly is.
LA is also pretty big, but also there's quite a lot of investment and action in Canada. You have, surprisingly enough, Newfoundland because of Colab, but there's also 2 or 3 startups in space tech that come from Newfoundland. But you also have Quebec and Toronto also, and a little bit of Vancouver. There's a bit of startup action there. But you've also got the UK is pretty huge. I found lots of startups in the UK, including some really like one of the unicorns I mentioned, PhysicsX. That's a UK firm.
Tell me a bit about that one. I haven't heard of that one before. What are they doing?
Physics on basically really high-end physics on the cloud for applied science to engineering, basically.
Okay, so they're going to be used by other people who are trying to do FEM stuff, or like where does it fit?
I think they're in the workflow for simulation engineers, basically.
Okay.
And they're one of the unicorns. They're over $1 billion valuation now. They're actually humongous.
I asked about that one just because it feels like it's I know it fits in the category, right, of extreme analysis, but in terms of how people conceive of what these startups are doing, because I think that's an important thing that people should get out of our episode today is, what does all this mean, right? Because years past, it was, well, there's some incremental thing. A startup thinks they got a nugget of a new idea, and then they're going to get bought by somebody, and it'll be folded into somebody's platform, that kind of thing. But some of these are different. They're almost, I know you put them in categories, but they're like new categories.
They are new categories. In fact, there's even some alliances that have formed around Colab. You have an alliance between Colab, Shaper 3D, Intop, Monolith, and drawing a blank on the other one. The Monolith just exited. They were purchased by Core Weaver, so they managed to do a nice little exit there.
Right.
But they're all sort of focused. They're all supported by the same VC, and they're all working on common problems and meeting up and stuff. I don't know of very many other relationships like that. I just know that there's a lot of. Let me just back up a second. So while I was doing this research, I also said it would be cool to talk to these guys, and ladies when I find them. And there are actually 3 or 4 startups I found that were started by women, like Masha doing Null Space, pretty awesome. But I thought, well, if I talk to the startups directly, I can learn a little bit more about what AI is in the real world. And one thing about that is like vibe coding has become this hype thing. And is that a thing? How do people actually build applications today using AI? And that's one of my core questions that I ask on these podcasts, like the one yesterday with Leo AI, but I've also done that with Quantient, and another couple hours I'll be doing that with C Infinity and Hestis, which are 2 other really cool ones.
Can you define vibe coding? I've had people ask me that, and I know Devin from First Resonance mentioned that as well in their architecture.
Well, vibe coding, the idea is you just use Cursor or Windsurf and you just say, build me a web page, and boom, it builds it, like Lovable or V0. I mean, there's a billion of them. And AI is very nice in order to build a rudimentary structure to maybe come up with a couple of ideas or angles you didn't see on something. But it doesn't necessarily build an application with all the corner cases, right? Mm-hmm. It's actually really bad at corner cases. But it's really good at creating test data, like just random test data that you need in order to test your application. It's really good at that. It's really good at looking at a code base and finding inconsistencies, doing refactoring. It's really good at
syntax,
that
little niggling details. It's pretty good at that.
Yeah. And what I'm finding talking to startups is that that's basically how they're using it. They're using it for those kinds of things. And they're finding that when I talked to Michael Core of Duro, it took him 4 years to build the first Duro. When he tried to use AI at the core of his process, it took him like 6 months to do a rewrite.
Wow.
And basically he wanted to use AI in the back end to do all the nasty plumbing, because at the end of the day, it's really good at that. I mean, it can figure out what's the input, what's the output, what's protocol do I use. That's what it's good for. It knows how to do that. Right. It doesn't necessarily know the meaning of the data behind it, but that's what we've got to teach it with the training.
So I want to kind of jump back to some of the pockets or the bubbles that you're seeing. So we didn't really mention Europe at all. You mentioned we started talking a little bit. You mentioned the UK, but I know that there's some space going on there. Like, where are you seeing things in Europe? And then maybe we can move into, in general, you said, BIM, you saw like there was 20 startups, whatever. Where are these bubbles you're seeing?
So yeah, I'm seeing a lot of startup activity happening in Germany, in France. There's quite a few, across Europe in general. But I've even found like an amazing one in Korea called CLO, and they're doing virtual fashion. So they're actually modeling with CAD, the way that clothes, fit a human body and all that kind of thing. It's pretty cool. I've not been able to talk to them yet, but they do have a cool product.
That makes me want to ask, we talked about it a little bit earlier, why these pop up where they do, right? Like 128 corridor, Boston, I get that. San Francisco, the money's there, I get that. You mentioned Newfoundland and space, maybe? I don't know if that one was, but I mean, okay, what about Germany? What about these other places in Korea? Well, is it universities? What is it?
Well, I think in Germany, in the Munich, so you have two primary, three, I'll say 2.5. So you've got Berlin, this is the capital, but it's also the German government's put a lot of money into incubators and startup places like, co-ops and everything. Then you have Munich because it's close to where all the cars are made. Right. So that's the innovation for BMW and Mercedes and stuff. And then Frankfurt, because that's where the money is. So there's a couple of startups around there. I think in South Korea, the South Koreans are very fashion oriented. They're very into that stuff. So I think that, some brilliant guys came out of school, decided not to move to the United States and actually build it in Seoul instead. So more power to them. There's a handful in Singapore because, again, Singapore also, they've got, every network cable that goes to Asia is pulled through Singapore. So they've got infrastructure and they've got money. So you see a few there. In fact, Spare Parts 3D, who I'll be interviewing next week, they do 3D parts and printing and stuff. And the guy actually lives in Singapore. He's French, but he's actually living there for whatever reason. And then I found a couple in Japan. Really hard to get information of China, of course, but I found actually a handful in India. There's one really awesome MES for pharma called Lucene. They only do pharma, but it's an MES just for pharma, which is cool. So I'd say that in terms of pockets, you've got outside the United States, I'd say it's primarily Germany and the UK with smaller pockets. France has some, but the crazy thing about France is there's almost no investment. You can only get a loan. There's no VCs no French people throwing money at these things, unfortunately. Less so than in some of the other places.
I know banking has its challenges there for sure.
We have a lot of challenges. But so in terms of other pockets, I mean, I'm seeing a lot around generative design, a lot around 3D printing, a bit around, because I did have another category where they were doing hardware, but they also had like really cool software. So like drones, some 3D printing, some of the robotics for industry. So I think there's a lot of innovation there as well. They're just harder to categorize. And I didn't want to go deep tech hardware. I wanted to stay deep tech kind of software because nobody's really covering it. There's already like lists by Insight Partners on just robotics. So I wanted to cover a space where nobody was at.
Interesting. So I want to ask, what does all this mean, right? And I've got maybe a follow-on question. This is a little tangential, but I mean, when you look at it all, Fino, what do you think it all means in terms of where we're headed in this space? Because you see kind of what people are inventing, what they're investing in.
I think that there's a little bit of frustration with maybe the big three because they don't move fast enough. They're all relatively, 2-3 years behind in terms of where everybody else is. So I think some customers just want to move faster and have access to the latest and greatest, and not just what was latest and greatest 3 years ago. I think there's also a feeling that because we have AI and because it's not in those tools, what can I do? And so a lot of these startup guys, the founders are like, oh my God, I could do all this cool stuff. And the investments, it's still an environment where there's a lot of investment money to go for it. So I think that you're just seeing a lot of ideation and a lot of creativity, and maybe those people don't necessarily want to work for a big three company, and they want to have their independence and do a startup adventure, and they're able to access that stuff without all the baggage and the technical debt that those bigger companies carry.
So that connects right to the tangential question I had about when you look at all these startups, and you mentioned it early on, in a lot of ways, AI has enabled some of what they're doing. But when you look at them just across those 300, how much of that portfolio is, it's AI tech doing something in this space versus, oh no, it's something different. The nugget, the seed of it is really unique. It's just AI helped them get there. They're not really doing AI. You know what I mean?
I know what you mean. I'd say that for the most part, the more intelligent ones have had some engineering idea, and they just use AI to accelerate their from to getting to A to B. Some people, like I talked to TD Engine yesterday. So Jeff Tao, he had already a tool that was doing IAoT for process industries and discrete, but he created an AI thing on top of that so that you could just create analytics automatically. Basically, it was pretty funny. He said it was like TikTok. He kept saying, it's like TikTok. And it was true. It would just basically show me, 50 graphs of, petrol over the time with water. And then you could say yes, no, you had to like or unlike. I called it Tinder, but he didn't like that too much. He preferred TikTok. But they would, you had all these graphs. You could just say thumbs up, thumbs down, and then they, gets you the graph and gives you another one. But it was super cool because it was, he said, usually you need an expert and an engineer. You got to pay him $250, $300 an hour, and maybe you'll come up with a dashboard that maybe means something to you. Whereas this tool is just basically proposing all the things that you could think of, and you're just selecting which one you like. And that's pretty cool. So that's the kind of things that AI can do for you, because it's much better at slicing and dicing through data than we are. At least it's faster at it, right?
Well, it's nice because it kind of recreates some interesting dynamics that some of the, I know, for example, First Resonance, they're targeting startups. So like they're trying to stay in that space. But a lot of these startups, you can see that, maybe the big three or others will start to snap them up and try to integrate some of this unique technology to help, develop and progress their product roadmaps.
There's an interesting tension there, though, right? One of the challenges that a lot of people see with the big three is they have snatched up technology, but it takes them a while to integrate it. And if this is about speed, then it's like, well, snatching up more of them isn't going to help.
True. And others, not just the big three.
No, but it's an interesting problem, right?
Yeah.
And what I find interesting, too, is we've seen we saw a big consolidation around EDA when Siemens bought Mentor. I think the last year or 2 years, we've seen CAE because of Ansys being bought by Synopsys, and now MSC moving from Hexagon to Cadence.
Well, there was the Altair acquisition from Siemens, right?
Altair acquisition from Siemens, CD Adapco before that. So I'm wondering, I think the next one might be CAM. I'm wondering, because already you've got Gibbs and Master that are owned by Sandvik, but you've got a ton of other littler ones. I'm wondering, which of the smaller CAM solutions are going to disappear, and if there's going to be like a mega CAM, or if it's just going to be Fusion and NX that are really the tools that most people use. I think some people use CATIA, but I think NX is kind of more recognized as a better CAM tool. And Fusion, as limited as its market is, it's still pretty excellent because of the acquisition of Delcam and so forth. So we'll see. It's a kind of an interesting marketplace, right?
Yeah, I would totally agree. It's any surprises for you along the way here?
Well, I was surprised to find that there were so many of them, and that. I forgot to mention that the overall value is $6 billion. So if you take all the startups combined, that's the size of Siemens, Autodesk, and DS, right? Which is just crazy that there's that much.
That is wild.
So I'm
that
wondering,
is pretty wild, yeah.
When you look at the data, the way Sim Data slices it up, is that data in there? I mean, the market size that we have, is it missing $6 or $7 billion that is in this alternative market, and how much will that market be disruptive to the big three over time? Will you be able to build your entire product and then just use something, an open platform like Aris to create a system of record kind of on the fly, rather than having to do the Teamcenter Windchill 3D experience thing? I don't know.
Yeah,
I think
that's a fascinating one. I love that one, right? Because of the space we're in, right? When we think about doing systems for people and sort of consulting on, hey, here's the business problem, here's the tech, how do I put it together? This patchwork idea comes up a lot of places. And is this suddenly, wow, now there's a huge market for all these pieces of the patchwork you could put together, and will AI help you stitch it together, right? With some backbone.
Well, and certainly the MCP, the protocol that Anthropic came out with earlier, that is going to be a major push for that. And yet, the complexity will come from the economic model, because basically the model of named users is sort of dead already, because the named user is an agent. So where do where do you actually draw the money, and who draws the money? Is it just OpenAI because you have to buy all the tokens? Is it? I haven't figured that out yet. Where and I think that might be. This is conjectural, but maybe that's one of the reasons why Siemens and PTC and DS are a bit slower at it, because they're trying to figure out the economics, because it's not very obvious where we go from here. I've seen a couple of papers, and I know that people are thinking about it, but I'm not sure we really have for engineering and the different disciplines that engineering has, it might be a different problem. I don't know if we're going to end up with more of a token-based thing like we've done in simulation forever, or if it's a named user thing like in CAD, but I think it's going to be some blend of the two somehow, because we've got both models, right? You do have named users, but you also have tokens.
I was thinking about this recently, about what is that model, and this consumption model, whether it's tokens or any other mode there. Isn't that challenging, though, for an industry that is supposed to be a lot of trial and error? Right. So it's like the more innovation you do, the more trial and error and failures you have, actually, the more you're consuming and you're penalized. Hold on, wait, is this all going to work?
Yeah, it's sort of like, my Airtable where I'm storing all this stuff. I think I burn all my AI credits in the first 15 minutes.
Right.
Like I run one thing, I got to wait a month. What I also found super disruptive was the announcement, was it last week, when OpenAI came out with their e-commerce APIs? That kind of throws everything out, right? Because suddenly the agents can charge each other stuff. So,
oh boy.
So
now it's getting interesting. Well, not that it's not interesting, but it's just.
So if you read about that stuff, that's really that's also a game changer. I don't know, and so maybe the smaller vendors actually win there, because they're much more agile and they're able to plug themselves into any infrastructure, whatever it looks like. Whereas the big ones,
right?
They have a bit of a. They have a stranglehold on it, because they've got the system of record, which we can't do away with. But they're also a lot slower at using getting the latest and greatest into the platform.
That's an interesting duality you just described there, right? It's like, well, we need the system of record because of the safety we all require and the things that people are building,
the traceability, and
right. But how do you move fast and still have that? And that's kind of the tension we're feeling with a lot of these startups. So I think great place to sort of bring it all back together in terms of what we're talking about today.
Right. It's disruptive, but it's almost like a different level of disruption. So there's just these variables of, there are things that have changed the markets and the products, but this in particular, this AI technology is really accelerating everything. So you're right, Jonathan. It is a level of tension.
And I think we're sort of at going from horses to cars, or maybe even horses to Formula One race cars.
Well, yeah, right.
Because the models are just going to be so different. The rate of change is so much faster, right?
Yes.
Yeah.
Well, I hate to say it, but we are coming up on our time, and it's always fun to have these conversations with you, Fino. We always learn so much. So thank you for being
absolutely.
here.
Invite me back.
Yeah, well, of course we will. So, Jonathan, what do we have today for what you've heard?
So I will first say, having you on, Fino, is one of the most challenging areas for me to summarize, right? Because we talk about so much and I get so invested and it's like, oh man.
Yes.
Anyway, but here's what I heard. I'll make a try at it. So first, in the research itself, right? So 300 or so startups that you looked at and buckets. You put them into interesting buckets, which I think is the first takeaway I've got. I'm going to try through the notes I made to go through those. Design intelligence, extreme analysis, adaptive manufacturing, cognitive thread, factory futures, BIM, education, augmented operations. What did I miss?
I said, well, I didn't say, I think I forgot to say it was bleeding edge BIM, I think I called it.
Bleeding edge BIM, okay.
Bleeding edge BIM.
But that's quite a collection of categories.
Education. Yeah, quite
engineering education, right? So when you look at that, there's a lot there, a lot going on. And I think we touched on a number of good examples of things that are sort of at the edges of those. Why you couldn't just use category names like CAD, right? Because it's more than that. It's different than that. Other things that I think I learned, at least through Julianne's question about some of where this is it really is scattered across the globe. There are a couple of logical sort of nexuses of, even if that's the right plural, but nexi, anyway, of where these things are. But it is scattered and there are things popping up and lots of ideas coming from new places. Implications, I thought that was interesting when we talked about that it really seems like there's a frustration with the pace we're moving in the industry as it is, maybe with the big three and the speed with which AI is impacting what their offerings are and what people can get out of those. So people are innovating. And then surprises. I thought it's interesting you pointed out one of your surprises was that there are so many of these, right? And you're finding more all the time. That is interesting. That's telling us something. And then the size of that market at 6 billion, when you kind of add it all up and you wonder, wait, is this even included in the total market we're looking at today? And then lastly, the disruption piece that you mentioned, I thought was really interesting. So on the economic model, on any number of things, but this really, what you're seeing is there could be a lot of disruption coming out of this. And it's not clear exactly where it's going to be, but there's something here, right? And you're seeing it. So that's what I took out of what we talked about today. But what did I miss?
I didn't mention much. I think you got it all. I'm just saying, watch this space because you blink, it's already changed, right? New model, new this, new that.
Yes.
It's crazy. But it's super exciting. And I think that we're just going to see even more innovation over time, which is cool. It's nice to be in an area where we're seeing new, cool engineering happening and not just the road. I feel almost like we're in a more exciting time than we were 10 years ago because we're pushing the envelope on so many things now.
Well, we're seeing the application of all this, right? Like the promise of AI was 10 years ago, and now it's like, wow, things are happening and we're getting results. And it's not widespread yet, right? The future's here. It's just not everywhere. But it's...
I got to wear shades, something like that. One of those
something like that.
When you mentioned something like, having all these applications having hundreds and hundreds of agents, you just get this sort of, kind of explosive idea of, okay... How are we going to do all that? Yeah, it's just a little mind-boggling, but it is. I would agree. Very, very exciting. I think this is. It's fun to be on this side of the business, and that every day you're always, there's something new and interesting going on. So keeps us all very busy.
And I don't know how you keep up, Fino.
I know.
I don't know either.
You are everywhere. I
need more coffee.
At the very least, yes. All right. Well, everybody,
come and listen to my podcast later on today with C Infinity and Hestis, and next week I'll have in use and Spare Part 3D.
And one of our favorites on yesterday, right? We had Oleg on there and somebody else.
Oleg and Leo. Yep. Mauer of Leo. Really exciting. Check those out. The AI Across the Product Lifecycle podcast. And then Julianne was a guest on the Future PLM podcast, which we're doing some interesting discussions and debates internally on that one.
Certainly
but we're talking about, next time we're going to talk about how whether PLM can help us avoid catastrophes, right? So it'll be interesting.
Yes.
Thank
You know,
you,
that's one
guys.
of Patrick's
Appreciate
favorite
you inviting
topics.
me.
So, yeah. All right. Well, everybody, thank you so
Always
much.
a pleasure.
Yes, thank you so much for your time today, Fino and Jonathan. Always a pleasure to
Anytime.
talk about these kinds of topics. Always interesting. And thank you everybody for tuning in. And please make sure to check out Fino's LinkedIn profile and his podcast that he's mentioning here. And with that, we hope everyone continues to stay sharp because you're going to need it.
Thanks, everybody.
Thanks. Bye.
Ciao. Thank you.
Thanks, Fino.
Thanks for being here and listening to this episode of Stay Sharp with Razor Leaf. If you like this podcast, please be sure to hit that like button. And hey, throw us a comment if you can. Tell us that you liked it. That would be wonderful. We'd love to hear from you. We like to see who's listening. And when you get a chance, subscribe to our podcast on your favorite podcast platform or follow us on YouTube. We've been doing a lot of YouTube shorts and making things a little bit more punchy. So please check that out too. We'd love your feedback on that. But if you have any questions, you want a topic you want to hear about, is there a guest you want to bring on, please leave us a comment or a post, and we'd love to hear from you. Or send us an email to podcast@razorleaf.com. Until next time, everybody, stay sharp.